The question says which of the following electronic configuration is not possible according to Hund's rule. In Hund's rule we have learned orbitals are singly filled with the spin then double filled. For example, we have as a subcell, in this case how many orbitals are there? Only one orbital. Okay, first single spin, then we have double spin. In P subcell how many orbitals are there? We have three orbitals, px, py and pz is there. Okay, you can see up to P subcell the detail is given in the electronic configuration. In case if you have to fill the 6 electrons, first of all singly fill, first spin, second spin, this is the third spin, then we have fourth spin, fifth spin, and this is the what? Sixth spin. Directly we cannot fill like this, it is not according to Hund's rule. Okay, now in case of s orbital, whether we apply Hund's rule or not, it goes like this because single orbital is there. So first option is correct only. Okay, first option is correct, 1s2 2s2. This is what we have. 4 electrons are there, so we can say in this case we have beryllium is there. Beryllium atomic number is 4 is there. Okay, in B option 3 electrons are there, we can say lithium is there. In this case also 1s2 2s1 is there. Okay, so we have orbital notation in this way, single spin is there. If I go for the C option, 1s2 completely filled, 2s2 completely filled, but now pay attention carefully. We have px orbital, py orbital and px orbital is there. It is supposed to be pz actually. It is supposed to be pz. So I corrected. Okay. So you can see, first of all, these orbitals are singly filled. One electron. Okay. So if I mention, in this case it is something, how many orbitals are there? We have 3 orbitals, 1 electron. It is what? Px, it is py and it is pz is there. So this is according to Hund's rule. Orbitals are filled with the spin, with single spin. Okay, then they are doubly filled. But now if you go for the D option, in this case 1s2 2s2 is okay, making sense, but we have 2px2. We have, this is what? Px, py and it is what? Pz is there. Okay, but in px directly they are filling 2 electrons. Before filling remaining orbital with the single spin, they are filling directly px orbital with 2 spin. That is not according to Hund's rule. First of all, condition is what? First of all, orbital should be singly filled with the spin, then doubly filled. Now in the start itself you can see they are filling the orbital with the 2 spin. That is not correct. So we can see option D does not follow Hund's rule. If you like this video, please share and subscribe to the channel.